Corrections for question number 1 to 5. In the recently concluded Winter Olympics, which was held for 5 days, the top 5 countries based on the total number of medals won at the end of the tournament were India, China, Japan, USA, and Russia in any order. The following table provides the partial information about the total number of medals won by these 5 countries on these 5 days. The missing figures are all greater than 1 and less than 5, which means 2, 3, 4. These are the numbers that we are supposed to fill at the blank empty cells. It is also known that the total number of medals won by each country on the 3 days for which the data is missing is always different. So that means that if we have 2 and 3 here, so we are supposed to put for 4 here. So this sequence or the order in which these values have to be put, it's not individual but the total. So suppose if we happen to put some numbers here whose sum is going to be, let's say 6, 2, 2, 2, then we cannot have the sum of the 3 empty cells of China or Japan or USA or Russia to be again 6. Okay, so it should be different from 6. On day 5, India, Japan, and Russia had won an equal number of medals. So day 5, India, Japan, and Russia, equal number of medals. So if this is N, this is N, this is N, they are going to be same values. On day 1, the number of medals won by the USA is unique and highest. Since it's going to be highest, we are pretty sure that it has to be 4 because we can only place 2, 3, and 4, and Japan already has 3. Also on day 2, Japan won the second highest number of medals. So since we already know that this is 8 and Russia already has a 2, so that means on day 2, Japan may have got a 3 or a 4. If Japan has got a 3, that means US and India, they both have got a 2. If Japan gets a 4, so we can have a combination for India and US for day 2. And no other country won the same number of medals as Japan on that day, which was kind of obvious. It's the second highest number. There is no replica of it. D statement, the total number of medals won by each of the 5 countries are 5 consecutive natural numbers. So the total number of medals, if we add the total medals for these 5 days for each country, it's going to be, it should not win more than 18 medals in total. So it should be less than 19. In other words, it can be 18 and below, right? So 18 and below is an acceptable total number of medals for any country. Now, if we look at the combinations of the sums, so if we take 2, 2, 2, we can have a sum as 6. And if we take 4, 4, 4, we can have a sum of 12. So 6 to 12, we have 7 possibilities, right? We can have a sum as 7 by taking 2, 2, 3. We can have the sum as 8 by taking 2, 2, 4. We can, or maybe 2, 3, 3. We can have a sum as 9 by taking 3, 3, 3, or maybe 3, 2, 4, 2, 3, 4. We can have similarly the sum as 10 and 11. So we have a total of 7 possibilities. Out of those 7, we are supposed to fill 5 of them. So having understood as to what the question is asking us to do and the conditions to a certain extent, we can now straight away move over to the questions and see, are we going to have caselets? We will prepare ourselves accordingly, or are we going to have definite, as in the table is going to be completely filled. So the first question is, which of the following countries won the maximum number of medals? And we see definite options. Second question says it's a theta 1, so definite again. Order the given options on which day which country won 4 medals, again a definite one. On day 4, how many countries won exactly 2 medals, again a definite one. Not exactly definite, one option says 1 or 2. Next question is, which country or countries has or have won as many medals on a day as on other 4 days together? Again, most probably a definite one. So 4 questions out of 5 questions are definite ones. So looks like the grid is going to be filled almost perfectly. Okay. So let's start filling this up. C statement says on day 5, India, Japan, and Russia, they had equal number of medals. So let's put N here. If anyone is known, we will fill the other two. On day 1, the number of medals won by the USA is unique and highest. So this has to be 4, no doubt about it. Also on day 2, Japan won the second highest number of medals. So it's going to be 3 or 4. Not sure about that right now. The missing figures are all less than 5 and greater than 1, as in only 2, 3, 4 allowed. The total number of medals won by each country on the 3 days is always different. We will keep on checking it. And it says the total number of medals is going to be 5 consecutive natural numbers, but it should be at most 18. So if we so far see as to what is the total number of medals these countries have won so far, we will see for India, it's already 7. For China, it's already 10. For Japan, it's already 3. For USA, this is already 10. And for Russia, this is already 11. Because for USA, we know it's 4, 1, and 5. So what we see is Russia has the largest total of medals. So we will have least cases if we start with Russia. Now, if we happen to put even the smallest numbers possible as 2, 2, 2, 11 plus 6 will give us 17. And since it says that we can have at most 18 medals for any particular country, so we can very much say that the total number of medals that we are going to put is going to be 6 or 7 for Russia. The missing sets, right? So N is going to be 2 or 3. If N is 2, 3 can go anywhere else as well. For Russia, we are only looking at this Russia column. So that gives us a lot of hint. So we can say that since we already have a total of 11, we can have another 6 or 7 for Russia. So we will have possibilities. So let's start with the cases because there is nothing else. So we'll have to do a bit of hit and try. Now, so 11 plus 6 is 17, 11 plus 7 is 18. So Russia can win a total of 17 or 18 medals, right? Since that is possible, what could be the combination of total number of medals for these 5 countries since they are consecutive numbers? So can we say, hold on, this is going to be 17 or 18. So can we say if Russia has 18, the other 4 numbers are going to be 17, 16, because we can't go beyond 18. And these are consecutive numbers because of statement E. And if Russia is going to be 17, then the other possibilities could be some other country has 18 and then 16 and 15 and 14. Or if Russia has 17, maybe Russia has the largest, while the other countries are going to have less than it, which is 13 to 17. So these are the 3 possibilities we have. If Russia has 18, the others have 14 to 17. If Russia has 17, the others can have 14 to 16 and then 18 or 13 to 16. Okay. So let's start with the first case where the total number of medals are, let's say, this one, consecutive, where 17 is the largest. So if we take total number of medals to be 17, so that tells us for sure that 9 plus 2 is 11, plus 2 plus 2 and plus 2, that is 17. So that means the others are 2. Right? Now the total number of medals that Russia has is 17. That is an addition of 6, right, from 11. So if we look at USA, which is already 10, can we have a 5 here so that it becomes 15? Yes, we can have 2 and 3 in any combination, right? Can we have 10 plus 6, that is 16 for USA? Yes, we can have 3 and 3. So that 16 and 17, these are the numbers. So USA could be 15 or 16. This is very much possible for USA. Now let's look at um, Japan. Japan already has 3 plus 2, 5. Can we make it smallest number, which is 13? So we need another 8. So we can have 3 plus 4, 7 plus 2, 9. 9 plus 4, 13. Yes, it is very much possible for China, for Japan as well. Let's go to China. China is already at 10. If we even take the smallest numbers, this is going to be plus 6, that is going to give us 16. But we can't take the same numbers here, right? Reason being, Russia already has a plus 6. China cannot have a plus 6 because of statement B. The sum of the medals on the missing days, this should be different. So we can't have 10 plus 6. And if we try to make it 10 plus 7, it will match with Russia, which is 17. That means we cannot have plus 6. We can't have plus 7. And if want to make it an addition of 5 so that it becomes 15, then the values that we'll be placing at the empty cells is going to be less than 2, which is again not allowed. So that tells us that 13, 14, 15, 16, 17, this combination of medal tally, it's not possible. So let's erase. Let's try the next one. Okay, let's restart. The second case is let's take which one? Let's take Russia as 18. Okay, so we already have 11, and then this is another 7, which is going to give us an 18. If this is 18, let's go to China, which already has a 10. So that means we added a 7. So in the case of China, we can add a 6 and get a 16. We cannot add 7 because 7 already goes to Russia, right? So this is going to be 16, very much possible. For this to be 16, that means everything has to be 2, 2, 2, another 6. These are the added ones. For a 17, we know that we can have 2, 2 and 3. So we can have 2 at n, or we can have 3 at n. These are the two possibilities, right? So suppose there is 2 at n. And the 3 is, it could be 3 also, right? Two possibilities. Okay. If we look at Japan, Japan is going to have 3 or 4. And we already have a 2. Okay, so if you look at Japan, this is going to be 3 plus 3, 6, 6 plus 2, 8. Or it could be 3, 3, 3, which is going to be 9. Or we can have 3, 4, 3, which is going to be 10. Now, we can't add a 6, we can't add a 7, so we can add a 5. So 8 plus 5 is 13, which doesn't exist. 8 plus 6 is 14, which does exist, but 6 is already taken. 8 plus 7 is 15, but 7 is already taken. 8 plus 8 is going to be 16, which is not taken. But the thing is, there is only one cell left and we can't extend it by so much, right? And if you start from 10, as in 3, 4, 3, that is already a 10. If we want to put a 5, this is going to be a 5. So the maximum number we can put is 4. So 10 plus 4 is going to be 14, right? So what we can have over here is, let's put a 4 here. And again, let's put a 4 here. Such that we have 4 plus 4, 8 plus 3, 11. 11 plus 3 is going to be 14. So we can have a 14 here. The values added at the missing cells is 4 plus 3, 7. 7 plus 4, that is 11. So 11 was added. So there was already a 3 and 11 was added. So this is 14. So 14 is taken, 16 is taken, 18 is taken. So we are supposed to now make 15 and 17. If we look at the USA, we already are at a 10, right? Sorry, we were already at a 6. You know, 4 was added later on. So now we are going to add 4. This has to be less than 4, so we can put a 3. So that is 7. And we need to put minimum 15. So this is a total of 13. So we are supposed to put a 2 here. So that the values that we have added is 9, which is unique, and we get a 15. Very much possible. Now, can we have a 17 here? Right now, we only see a 7, so we need a 10. And for a 10, we would need 4, 4, and 2. Since here, if we have chosen 3 for Japan, we are going to have a 3. That means we are supposed to have 7 from here. We can't take a 4 here because Japan had the largest on day 2. So it has to be 3. Day 3, India is going to be 4. So that we can add 10 to it, and this turns out to be 17. For Russia, we are supposed to put a 7. Since we have taken a 3 here, that means the other values are going to be 2. So we can say that this is a very much a possibility. And we can also say that on day 2 and day 4 for USA, since there was no fixed thing, so we can have 3, 2 or 2, 3 here, because we have to make the sum as 5 only, right? And this makes n as 3 as well. Okay. So that means Russia taking 18, USA taking 15, Japan taking 14, China taking 16, and India taking 17. It's a very much feasible scenario, right? Should we go ahead and check the next scenario? Right. Since this is also a possibility, and we have seen that there was a question where there was a possibility, there was an option which gives us a hint that you can have 1 or 2 medals. So we should take that 17 as well. So let's erase everything. And of course, this is a quite difficult set. This is not an easy one. So erasing everything that we have placed beforehand. Okay. So we know that for day 2, okay, for day 2, we don't know that this is 4. For day 1 for USA, we know that this is highest, which is 4. So this is what we know. For Russia, we are already at 11, and we want to make this as 17. Okay. So we need a 6. If we need a 6, that means these are all going to be 2s. That means the others are going to be 2s. If we look at Japan, this is already at 10. So in order to make a 17, we need to put 7 more, and 7 can be placed as 2, 2, 3. So we can have 2, 2, 3 in any combination here, because there is nothing about China that has to be fixed. If we look at USA, we are already at 10. Since, sorry, this is 7, not 17. So 17 is already taken for USA. For China, it should be 18, sorry. let's say, so this is 2, 3, 3 in some order. 18 is taken, 17 is taken. So we need to have a 6. In order to have a 6, the problem is there will be repetition of the total number of medals added in the 3 missing cells for USA and Russia. So we can't put a 6 here. Can we put a 7 here? So if we put a 7 here, the thing is we will have 6, 7 and 8 as unique additions, but then 10 plus 7 is also 17, 11 plus 6 is also 17. If we don't make it for USA, if we make this as 8, the problem will stay in the case of China. So China or USA is going to contradict the 2 conditions here. Either condition B or condition E will get contradicted. So that forces us to go back to the previous combination. These were already filled. And we know that Russia is already at 11. So we need a further 7. For a further 7, we had to take 2, 2 and 3 here. Since Russia on day 5 is 3, Japan and India are also 3. USA is already at 10. And USA is supposed to take, it was 15. So it was a 5. So for a 5, we can have 2, 3 or a 3, 2. For China, we were already at a 10. So we are supposed to take 16 here. So for a 16, we need 6. So that is going to be all of them being 2. India is already at 7. We needed a 17. So this is 10. So out of which 3 is already there. So we need another 7. For another 7, for day 2, we can't take a 4. So day 3 has to be a 4 and day 2 has to be a 3. Since Japan is the highest, and so far we see on day 2, India has got definitely the value 3. So Japan has to be 4. So for Japan, we were already at a 3. We can see that 17 is taken by India, 16 is taken by China, 18 is taken by Russia, 15 is taken by USA. So Japan needs to have a 14. So we need 11. Out of that, 4 plus 3 is 7. 7 plus 4 is 11. So on day 4, Japan is going to be 4. Let's move over to the questions. Question number 1. Which of the following countries won the maximum number of medals? We know that this is Russia with 18 medals. Answer is going to be option D. Question number 2. What is the total number of medals won by these 5 countries on day 5? On day 5, the total number of medals won is 3 plus 2 plus 3 plus 5 plus 3, which is going to be 16. Since it's a theta question, we are supposed to type in 16. Question number 3. Out of the given options, on which day which country won 4 medals? Day 3, China. No. Day 5, Japan. Nobody wins 4 medals on day 5. Day 2, USA. No. Day 3, India. Yes. So answer is going to be option D. Question number 4. On day 4, how many countries won exactly 2 medals? So on day 4, China definitely won exactly 2 medals. And USA may win exactly 2 medals. So we can say there is going to be 1 country for sure, China, or we may have 2 countries, China and USA. So since we have an option which says 1 or 2, so D is going to be the answer. Question number 5. Which country or countries has or have won as many medals on a day as on other 4 days together? So if you look at India, India has won maximum 7, where in the other days it was 10. So India is not there. So option A is ruled out and option C is ruled out. Now between B and D, China is definitely there, where it says 8 and the sum of the medals on the other 4 days is also 8. Now we need to check between Russia and USA. For USA, we don't see a large number. At Russia, we see 9, which is going to be sum of the other 4 days middle tally, which is 6 plus 3, 9. So it's going to be China and Russia. So option B is the answer.